Alright, in the first problem, it's asking to find the time required to increase the speed and the distance traveled during this time interval. So we're given this equation. I plotted it on this graph. This line represents the propeller, this is the net thrust, and this is the drag. Here's my free body diagram of the boat, and then using the kinematic equations, I solved for t using this equation, did the integration, and then plugged in the a to the bottom. So then I ended up with this, and then I plugged in the 2.5 and the 1, and then got a t of 18.8 seconds. For this next one, I use this kinematic equation. Similar process, I divided both sides by a, and got dx equals v dv over a, and then integrated and got x equals 36.14 meters. The next problem is a pulley problem. So we have two pulleys going up on this boulder and pallet, and then the force of gravity is acting down on it, and then a truck is pulling it to the left with an acceleration of 1 foot per second. Now, since there's two pulleys, the acceleration of this system is going to be 0.5 feet per second squared. So using Newton's second law, F equals ma, so I plugged the 2t and then the force of gravity of the weight, and then set that equal to mass times acceleration, and got a t of 609.32 pounds. And then from there, I plugged in it into this equation. So I have this free body diagram, and then I'm finding basically the frictional force. So this force right here. So I have F minus T, which is the sum of the forces, equals ma, and then F plus, add t to both sides, it's F equals ma plus t, and then F is, the frictional force is 765 pounds. Next part is to find the force between the boulder and the pallet. So there's a normal force going up and a weight going down, and then additionally there's the mass and acceleration of it being pulled up. So yeah, plugged those in, and then got a total of 1,016 pounds. For number 3, there's a tether ball going around a pole, and then it's asking to find the angle that the cord forms with the pole and the tension in the cord. So I have my diagram here. I have my sum of my forces. I have this equation where it's rho equals L times sine theta. We solve for it on the right here. As you can see, plug this in for t from here, and then use this rule or like trick to make this equal to 1 minus cosine squared theta, and then plugged it in and got 49.9 degrees. And then I simply just put the theta back into this equation from up here and got 6.85. The next part is a wrecking ball with a steel wire. It's asking for the tension at C in the high up position when velocity is 0, and then when velocity is 13.2 in the bottom position. So in the highest position, velocity is going to be 0, so is acceleration, because it's statically moving, it's static and it's changing direction. So I set that equal to 0 and got 122.2 pounds. And then for this one, I just have simply tension and then the weight, and then have that equal to MA, and then I got a tension of 145.6 pounds. And the next problem is asking about a turntable and determining the coefficient of friction, of static friction. So all we had to determine was the tangential and normal acceleration. And so I plugged in my sum of my forces, MA and MA in the normal and tangential directions, and then you square root it to get this, and then plug in AN to be this, and then this is the formula for force, normal force, and these coefficient of static friction, and then I solved for it when I plugged in this back into here. Got 0.236. The next problem is asking for the mass of the sun and the acceleration of gravity at the surface of the sun. So we know these, we have this equation, we convert to the velocity, we have our GM as this, and then to solve for M, we can just divide mg divided by g, and then we get 1.998 times 10 to 30 kilograms. For the radius of the sun, we know that it's this, and so we can plug it into this equation, solve for g, and then plug in all of our knowns, and we get a gravity of 276 meters per second squared. The next one is asking to show that F is inversely proportional to the square root of the square of the distance r from the particle at 0. So we have r naught, we have our particle, and we have our origin. I meant to say to O, not 0. And then we have all of these equations, and then essentially we just plug it in and rearrange until we get F into this format. And since these are all constants, we can essentially ignore them because they're not going to be changing with, as it moves around. So we now know that F is equal to 1 over r squared, which is proportional or inversely proportional. The next problem is asking for the increase in speed required at A to achieve escape velocity and enter parabolic orbit. So we have these equations, and then also the decrease in speed and the eccentricity of the elliptic orbit. So we have this, we have our radius, we have the V circle, we have all these equations, and we plug them in, and then we solve for VA using H and RA. We solved H through this equation right here with all of our knowns, which we solved for above. And then part B is asking for the decrease, and we have this equation, and it just ends up being 725 meters per second. And then the next problem is solving for eccentricity, and we have this equation CH squared over GM. And then we solved for C above, got 19.6 to 3 times 10 to the negative 9 meter per meter. And then we get a E or epsilon value of 0.33. And the next problem is asking for us to prove or show that the curvature of each point can be expressed as 1 over rho equals 1/2 1 r naught plus r plus 1 over r1. So we have these equations, these two, and we know that theta b equals theta a plus 180, and from that we can prove that, or derive that cosine theta a equals negative cosine theta b, and we then can add those two together and get 2gm over h squared, and then just continue to plug those in and we get the equation.